Guys, new here, new video, and today we're gonna be counting in different numeral systems, and we're gonna try counting in binary, base 12, also known as duodecimal, and base 16, also known as hexadecimal, because it's more these two. For binary and hexadecimal, it's important to know this if you're dealing with computers, whereas base 12 not so much. Base 12 is mainly used for like music. It's like it's also used for telling the time with analog clocks, like, because you know how it's like 1 to 12, yeah, or it doesn't say 0 to 12, it just says 1 to 12, or 12 to 1, or 1 to 12. I mean, sorry, but yeah. I'll show you in how I count on the finger later on. Hey guys, I'm gonna try to show you how to count in binary using pen and paper. Well, we've got a paper here, I've got a pen here in my other hand, and I'll show you how to count using binary. So usually in computers you use binary, because not usually, most of the time they use binary, but anyways, they use it they use 8 bits because there's one byte, because 8 bits is 1 byte, so they use it in octets I think, yeah. Anyways, we only need 8 digits for this, so that means 8 place values. So that means, so just like in the decimal, because we're dealing with base 2, right? Base 10 is decimal because it's there's 10 digits. In base 2 it's binary, so it's just 1 and 0, 1s and 0s, whereas decimal is 0 to 9. That's decimal, or base 10. But anyways, let's get back to it. So in order to count in binary, it's the same thing as you do in decimal. So in decimal you got the 1, the 10, the 100, 1000, etc. What's going on? Sorry about that. Anyways, same with binary. So you got the 1 and the 2, the 4, the 8, 16, but when you're dealing with computers, you only go up to 128, because it only goes up to the 8th place value. Anyways, one method you can try do for counting in binary, instead of remembering all that, you can just do 2 times to the power 2 to the power of, or just do, instead of 2 times 1 to the power of, sorry about that, it's just 2 to the power of 2, or 2 to the power of 1, and then 2 to the power of 3, 2 to the power of 4, etc. Because what it is, when they say power, the indices or the index, it means 2 times 2 times 2. Like, for example, 2 cubed is 2 times 2 times 2, or 2 squared is 2 times 2, which is 4, and that's 8. Sorry, so bad at this. 2 to the power of 4 is 16, etc. That's one way you could do it. Another way you could do it is counting it by your fingers. I'll just show you an example first. So let's say 5 in decimal, and we want to convert it to binary, right? What you do, because what we just did it here, right? So there's 1 here, 0, and 1. How did I do that? Because there's 4 and then there's a 1. 4 plus 1 equals 5. You don't put 4 plus 2, that would be 6. If it was 4 plus 1, that's 5. If it was 2 plus 1, that's 3. So you just put 1 for 3. Whereas just 1, just write 1. No other numbers. But yeah, that's binary. I'll show you how to count it in your fingers, right? Same thing, but since we're dealing with 8 bits or 1 byte, because it's octets in computers, right? You only use 8 digits, so 8 fingers. So like we did there with the 101 before 5, you do it here. Hold on, I can't do it. That's how you do 5. We'll start counting from 0. So this is 0. That's 1, 2, 3, and then 4. I can't hold it still, that's why it's hard. And then 5, and 6, and then 7. Because 7 is 3 plus 4, right? Because 2 plus 1 is 3, 3 plus 4 is 7. That's how you do it. Again. But this time, we're dealing with IP addresses. So, for example, in the beginning of an IPv4 address, you get something like 192, right? 192. How do you do that in binary? You can do that using your fingers, but first, I'll show you how to calculate it, why it's this. How did you get 92? How I remember it is 192 is close to the 128 and then plus 64. That's how I remember it, because 128 plus 64, so let's just do it right now, right here. It's 12, and then 3 plus 6, that's 9, and that's 192. There you go, see? That's easy. But how do you do that in binary? How do you convert it to binary? You convert it to binary like this, right? Because we had the two values here, the two place values, you only need to write 1, 1, and then, because it's on the left end of the higher end of the place values. So since we're dealing with octets, you're only doing that, and then it'll be 4 zeros. That's how you do it. And then you can do that using your fingers, right? Like this. Wait, hold on. Since we're going like that, right? I'll just show you. So it's like this. I'm using this as an example. So it's like that. That's 192. Another example is Subnet Mask. So Subnet Mask is usually something like 255, 255, 255, something like that. So instead of doing like this, right? It's this, because you're doing 255, 255. Why? Because you're actually going to the highest number in that place value in the octet. That's the highest number you can go, because just like in the highest number in for example, in the decimal system is 9 in the units, so it's 0 to 9, right? That's how we know. And then you can do the same thing for 10 to 99, and then yeah, it's like that. It's a similar case with binary. So see, like instead of 256, because 256 is the new place value 256, but it's the one below it. So that's why you gotta write that's why it's 1 1 1 1 1 1 1 1 equals 255. Because if you go to 56, then it would be written like this: 0 0 0 0 0 0 0 0 in binary, of course. That's 256. I mean, right? It's so bad. So yeah, and then yeah, that's binary. Here's another advice or some tips. So we're going from we went from binary, and now we're up to duodecimal, or also known as base 12. So there's 12 numbers. I mean, not 12 numbers. There's 12 digits or 12 bases. You know what I mean? So the extra numbers are A and B, which represents 10 and 11, because that's the highest number in base 12, or duodecimal. You know? So say for example, what's it called? So if it's like BB is what? What's BB? That's a duodecimal number. What is it? So since like I showed you in the previous video, like 1 and then the 10 and then the 100, etc. Just put the commas there so it doesn't get confused. So yeah, what you do is the same thing, except you're going by 12s. So that's 144, right? So BB, or B, what is B anyway? So B is 11, right? What's B? So B is here, so it's B and then B. You don't put actually no, that's wrong. It's B here, because I'll show you in a minute. How did I get that? How do I get there? I meant so BB is actually, it's sort of like 99 basically. So, but it's not 100, right? It's like this. It's like 100, but it's not 100. It's just 1 unit before the 100 place value in the decimal. I'm just comparing it to decimal, right? The duodecimal, the BB. So how do we get to BB? Well, There's one way. Since this is like 99, it's sort of like 99, it's 1 unit before. What you do is 12 to the power of 3 minus 1. And that's how you get 143, because we know that 12 times 12 is 144. You minus the 1, you get 143, and that's B. Yeah. Or alternatively, you could do this as well. You times B by each place value. So B times what? B times 1 is what? 11. And then B times 12, which is 11 times 12, is 121. What is it? I don't know. Is it B times 12? Times 12. I'm a bit confused, hang on. There's some technical difficulties, mathematical errors here. I'm trying to figure this out. 11 times 12 is 132. Oh yeah, it's 132, sorry. It's not 121, so bad. And plus that, you get 143. 143, that's another way as well. Instead of doing 12 to the power of 3 minus 1. It's just the same answer, just different methods. But yeah, let's go to base 16 now. Base 16 is also known as hexadecimal. Let's just find a different page. Let's go to a new page actually. Base 16 or hexadecimal is 60 numbers, so the extra numbers are A to F, and how you remember it, that's how I remember it. So it's 10 to 15, because 15 is the highest number in hexadecimal. It's used in computers, and I'll show you in a minute how to get to base 16. It's the same principle of like FF, for example, right? FF is what? We're gonna try to find FF. Remember, this is like the ones symbols. This is the 1 units. This is the 16 units. So how we get that is F times 1, and then F, another one here, F times 16. So what is F? F is 15. So 15 times 1 is, I don't know this one though. I'm gonna have to do it here. So it's really using pen and paper. Got no calculator on me right now. 6 times 5 is 30. 5 times 1 is 5. Plus 3 is 80. 1 times 6 is 6. 1 times 1 is 1. You add that together. That's 14. 240. It's 240. Then you add that together and you get 255. Yes, that's how you get it. Which is also used in web colors, like for example, usually they have hex triplets like FF, FF, F. The hex triplets, so triplets, you divide them like that. There's 255, 255, 255, but it's like this. And it's hash. There's a hashtag. There's a number for a color. It's a color code. So for example, I think white is hashtag. I have it here somewhere. Hashtag FFFFF. That's what we got, right? Yeah, that's white. Yeah, that's definitely white. Yeah, it's white because it's the reason why is because this is red. It's RGB. So it's also written as 255. So it's 100%, 100%, 100% in the RGB. 100% red, 100% green, 100% blue. That's why it's white. So that's it.